All right, I can see our participant count clicking up. We're going to start the webinar and away we go. My name is Denise Olson. I'm the Director of Education Marketing at GBH, formerly WGBH, specifically from GBH Education. And if you're new to us, you may not know that GBH has an education division, but we do, and we focus on creating learning resources for grades pre-K through 12. We do community outreach projects and events. We go to conferences, we hold conferences, we do webinars, lots of things to support teachers and students. Next slide, please. So GBH has been a leader in the public media system for over 70 years. On the left there, you'll see many of the brands that you're probably familiar with, favorite shows. We're going to be hearing from our friends at Nova tonight. And GBH is one of the largest contributors of broadcasts and resources and other media to the PBS and PBS learning media systems. Next slide, please. Much of the work we do can be found on PBS Learning Media, which is a free digital learning platform for pre-K through 12. PBS Learning Media is a partnership of PBS and GBH with resources for all disciplines and grade bands, and they are contextualized for the classroom with instructional support materials. And the platform contains media from across the PBS system and our partners at organizations like NASA, NOAA, and Smithsonian. So here's the landing page. Go back, please. Here's the landing page for PBS Learning Media. And if you don't know it, we'd encourage you to go check it out. It's free, and even creating an account is free. And with an account, you can do lots of things like connect with Google Classroom, Schoology, other student rostering tools, folders. And we'll be saying a little bit more about PBS Learning Media and the resources on it at the end of the webinar. So I would like to introduce our two presenters for tonight. First is Shawn Stevens, who's Director of STEM Curriculum and Instruction at GBH. And prior to joining us, she spent several years doing educational research focused on student and teacher learning. And she developed instructional materials for both formal and informal settings. And she was part of the team that defined the core ideas and progressions for physical science for a framework for K through 12 science education, which was the foundation for the next generation science standards. And we're very excited to welcome our special guest, Charles Fulco. Charles is a science teacher in New York. He's he's a NASA JPL Solar System Ambassador and an Education and Public Outreach Coordinator for the 2024 Great North American Total Solar Eclipse. He's also a presenter and author with NSTA, AAS, darksky.org, and other educational, astronomical, and environmental associations. So welcome to Shawn and Charles, and now we're going to turn it over to them. Shawn, to you.
Thanks, Denise, and thanks to everybody for taking their time, coming tonight and taking some time out to spend with us. Do you have a next slide, please? So this is just what we're going to cover tonight. We've gone through the introductions, and we're going to first hit a little Eclipse basics, a review for you all, while we're showing you some resources and ideas for things that you can do with your students. And then we'll discuss how you can prepare for viewing, for this viewing of the eclipse. And then Nova will come in and tell you about an eclipse event or two that they have. And then we'll have some wrap up. And then hopefully we should have a lot of time for Q&A. Okay, so next slide. Thank you also for putting in and providing so many questions. We're really excited about how interested you all are. Charles and I did our best to answer as many as we can in our presentation, but again, there'll be time afterwards to answer questions, and you can put them in the chat as they come to you, and we'll be tracking them, and we can come back to them if we can't manage to answer them on the fly or in the chat. Okay, so first off, basic thing. What is a total solar eclipse? All that is just that the moon is moving in front of the sun, completely covering it. This is a rare occurrence, and in a single location, it's almost 400 years before it repeats. When this happens, it's like total dark, almost total darkness in the daytime, so it can be disorienting both to animals and humans, and so it's can affect their behavior. Next slide, please. This is just a diagram. It's not to scale. Sun would be much bigger and further away if it was. But you can see this is what's required for a solar eclipse to occur. So the sun, the moon, and Earth are all lined up. And there's the moon's shadow is there hitting the surface of the Earth. So next slide, please. The fact that we can have a total solar eclipse is really an astronomical coincidence. Because if you look at the moon, it's tiny compared to the sun. It's 400 times smaller, in fact. So how can it completely block the light from the sun? Next, please. Well, it turns out that the moon is also 400 times closer to us. So they appear to be the same size when we look at them in the sky. I just wanted to let you know that pretty much everything that we're talking about can be found on PBS Learning Media, and usually the names of the resources are in the bottom corner of the slide, and they'll also be on a resource list that you will all get a link to tomorrow. So this coincidence is a good opportunity for a modeling activity, especially for young kids, right? So how can you take a small ball or sphere and how can that block out something that's much bigger? You want to click the video? So this is something that even like kindergartners could probably really grapple with and try to figure out and come up with a simple solution. For older kids, you can dig into the geometry of this and give them a couple of the variables and the dimensions and have them calculate it. Next, please. Okay, so back to our diagram here. So why can't the whole planet see a total eclipse? So if you zoom in and kind of look at where that shadow is, there are kind of two parts to the shadow. There's the darker part, which is called the umbra, and then the penumbra is the bigger, broader, and it's just a little lighter gray. Next slide, please. So when we're looking at this from another angle with the sun behind us, you can get a better idea of how special it is to be able to see the total eclipse. So the light gray shadow is covering more than the entire North America, but then that little cone is going down, and it's that's where people can see the total solar eclipse in that umbra, and that's like 100 miles across or something like that. So a very select area can see the total eclipse. Next, please. If you wanted to show this and discuss this with kids, all shadows do this. So even, you know, hand puppet shadows have both the umbra and penumbra. This was actually taken from professional development video on PBS Learning Media of a teacher discussing how he likes to teach about eclipses, and some video demonstrating his strategies in the classroom. Next, please. Okay, so this video, and you can play it now, is just an animated visualization of the satellite data from the 2017 eclipse. So you can see how it's just passing over North America right there. So lots of different ways to see it and model it for your students. Next, please. Okay. So now, who is going to be able to see the total eclipse on April 8th? This is a map from NASA, and there are a lot of them out there. That black stripe, dark stripe going up across, that's the path of totality. It's about 100 miles wide. So kind of pretty narrow, but the whole lower 48 here is going to be able to see at least a partial eclipse. The amount will vary. Up in Seattle, it's about 30%. For us in Boston, it's about 93 or so percent. So next, please. You can find out where in several places in the resource list, but we'll show you a couple tonight, but this one here summarizes it all really nicely, timeanddate.com/eclipse. It says when it begins, and that's when the moon is going to start to traverse across the sun. The maximum is when you're going to reach totality, or whatever, or as close as you would get to it. So this is for Boston. So this is saying it's 93%. And then there's a little simulation to show you kind of what it's going to look like in your area. Next slide, please. So this is another site, Eclipse 2024.org, which you can also find all of this information. And this has kind of nice, slightly different kinds of simulations to show what you may not see. So this is, these are simulations of the eclipse, what it'll look like in Toronto. And that one is 99.8% covered. So only 0.2% of the sun's light is going to be visible. So can you play the video, please? So you can see it pretty much is gone and everything's covered, right? So you think there's not going to be much light. But this site also lets you kind of simulate the glare of the sun. So we can play the next video. So as you can see, even with just 0.2% of the light from the sun coming, we'd still need to use your special eclipse glasses. There's too much glare and you never really get that full total eclipse kind of look. Next slide. So this is the total eclipse, and this is in Buffalo, which is like just across the lake. And you play this video. So this one also has the glare, but you can see the difference that 0.2% makes. So also, if you notice at the top bar there, that red bar, that's all that happens to be that's indicating when the filter or your eclipse glasses are needed. So when it is at totality, and it has to be at absolute completely covered in totality, then you don't need to wear your eclipse glasses, and you can look at it with your naked eyes. But, playing this type of simulation can help prepare your students for what to expect, and as you set up your rules and procedures for viewing the eclipse. Sending it to you, Charles.
Thanks, Shawn. Thanks everybody for coming out. And I just want to notice one thing, that the beginning video of that mystery eclipse, I noticed that a friend of mine, Daniel Fisher, who's probably in Germany as we speak, got the correct answer. It was in Patagonia in a town called El Calafate, which Daniel and I saw it back in 2010. So congratulations, Daniel, and anybody else who got that. Okay, Shawn, this is as you were saying, this is on Dan McGlon's eclipse2024.org website. It's a wonderful website with lots of resources for teachers, even beyond the eclipse. And what I like about it is it has a very, very realistic simulator. You can actually zoom in using the left vertical bar. You can slide the lower sliders for advancing it quickly, and then advancing it kind of like fine tuning it. And then it has a time, the lower right, with maximum coverage. In this case, right now, it's showing 70% magnitude. So the magnitude simply means, in simple terms, how much of the sun is being covered by the moon. So when you have 100%, obviously that would be a total eclipse. And Toronto's was, as you said, 99.8%, which still is not good enough. So this is a really wonderful website. Gives you the again, the warnings when to put your glasses on. If you go up to the top left, you can see that little box called glare. If you click that box, that will show you what it's like if you were not wearing eclipse glasses. And you can see that even 0.2% is not enough to see the corona or see all the other phenomena associated with totality. So this is one of the best ways to show that. For people to say, well, why do I have to go to totality when I could see 99%? Well, here's your answer. You just saw it. The sun is extremely bright, and even 1% of sunlight remaining is still 10,000 times brighter than totality. So it's really, really super urgent that everybody gets themselves to the path of totality. Next slide. Shawn, did you want to take this one, or do you want me to take it?
I can do it.
Okay.
So why are eclipses so rare? Can you play the video, please? So if we're thinking about the lunar cycle, the moon orbiting Earth, you'd think that every month everything is all lined up at the new moon. So why don't we have an eclipse every month? Next slide, please. Some of that is because we're thinking about this in 2 dimensions, but if we're thinking in 3 dimensions, the sun, Earth, and moon are not always on the same plane. So what that means is that the sun's orbit or the Earth's orbit around the sun is in a slightly different plane by 5 degrees. The moon's orbit is tilted up by 5 degrees. And next, please. And so that means that there are only a couple places where the plane intersects. So they're only during a lunar cycle. And then plus, next, please, we need to have the new moon. And so everything has to be, all of that has to happen so that we can get the total solar eclipse. Next slide. So why does that matter? This video is going to help us see how, so we've got the sun over there coming from the left, and Earth is in the middle, and the moon going around. So you can see here, because it's not quite at the right plane, the shadow's going underneath the Earth. So we're not going to see any eclipse at all. Then here, a couple months later, everything is kind of lined up. It's all in the same plane. You can see that it's pointing at Earth. And so this month, we would actually get an eclipse, a solar eclipse. So Solar eclipses actually aren't as rare as we think. You know, I mean, they do happen at least twice a year, but not necessarily a total solar eclipse, but at least a partial. And they can occur as much as 5 times per year. But the total solar eclipses occur about every 18 months, but they just occur somewhere. Not always at like inconvenient places to view them, like middle of the ocean or the middle of nowhere. So for us, we always think of them as being rare. Next slide, please. The total lunar eclipses seem more frequent because the Earth's shadow, so everything's lined up in the opposite, so that Earth is between the moon and the sun. So the Earth's shadow covers the moon completely, and pretty much everybody on the dark side of Earth can see this. And so they feel less rare because a lot more people can see each event. Next slide, please.
Okay, so a Saros cycle was a pattern that was recognized centuries ago, way before the Renaissance period, that people like the Babylonians and other cultures recognized that eclipses occur in recognizable patterns. And the Saros cycle is probably the most famous of these patterns, where every 18 years, 11 days, and 8 hours, you get a very similar eclipse to the one that preceded it, that interval earlier. So, for instance, we have this eclipse coming up on April 8th, 2024. If you subtract one Saros interval, you get March 29th, 2006. And then you have the current one. And then if you want to project this one Saros interval into the future, you'll get April 20th, 2042, which seems, that date seems a long way away, but it's only 18 years away. So every eclipse also belongs to what's called a Saros. It's assigned a number, basically. Every eclipse, whether it's solar or lunar, is assigned a Saros number. In this case, this is Saros 139, which has still got a ways to go with producing, with each interval succeeding. It's going to produce longer and longer totalities until something really cool is going to happen in 2186. We're going to get a 7-minute and 29-second eclipse, which is 2 seconds short of the theoretical maximum. And that's going to be the longest totality in 10,000 years. So I'm planning actually to be there for that one too. So the Saroses also have a very cool way of allowing even school children to say, hey, when's the next one going to be? It won't tell you exactly where it is. It'll tell you, you know, you could probably figure out within a reasonable part of the hemisphere, but you won't be able to tell exactly where it is just by the Saros cycle. That's for other computations. But it will tell you almost, you know, to the day, give or take a leap year in between. Sometimes it's 10 days, sometimes it's 11. But you'll have a reasonable estimate of when the next eclipse will occur. And it's really fun to even have kids who are just beginning to recognize patterns and can work with dates and can work with a calendar to say, hey, when's the one, you know, after this going to occur? And you know, and when did the last one in this Saros cycle occur? So once kids recognize patterns, and it's about NGS standards, children as young as first grade are required to recognize predictable patterns of motion in the sky. So this is kind of a nice little add-on to that. Next slide. Here's a great way. This is from NASA, and I believe courtesy of GreatAmericanEclipse.com. This is an example of how the intervals really repeat themselves in similar patterns, similar duration, similar shape of the path. You could really see that. So the extra 8 hours, though, that occurs in the Saros cycle, you have the 18 years, 11 days. Then you have that 8 hours. And during that 8 hours, the Earth will have rotated 1/3 of the way around on its axis. So placing the eclipse 120 degrees westward from where it was 18 years, 11 days, and 8 hours earlier. So that's why people won't see the same eclipse one Saros interval later, because their globe mates 1/3 of the way around the world will see it. Then another Saros will put it another 120 to the west. And finally, 54 years and 1 month later, which would be a triple Saros, or here's a good word for you, the exoligmos, that will put it back in the same general longitude as where it was 54 years ago. So for instance, my first eclipse was March 7th, 1970. I saw that as an 8-year-old in New York. And for me, this is my exoligmos. This is my triple Cyrus coming around again. Same patterns, similar duration, and it's going to come up again the East Coast, but now shift a little further west. So instead of Martha's Vineyard being and Virginia Beach and Norfolk and Georgia and Florida having totality, now it's going to be inland a little bit in Texas and the Midwest and Buffalo and Rochester and northern New England. So even though it's quite similar, there's still a little bit of a discrepancy with longitude. So you really need those computers to predict where exactly it's going to be down to the meter these days. Next. And Shawn, you want to take this one with the Babylonians?
Sure. So it turns out over 2,000 years ago, the Babylonians actually deduced these star cycles. They after hundreds of years of really detailed observations and recording, they were able to deduce these. They were able to predict when they would occur, but not as well where they would occur. It wasn't until 1715, I think, that Halley was able to make the first prediction of where an eclipse was going to occur. The Maya also could predict a lot of astronomical phenomena, including eclipses. This here is an eclipse table. So these are just a couple possibilities if you want to explore some other cultures and how they explored and learned about astronomy in the past.
Yeah, one thing I want to mention was Edmund Halley of Halley's Comet fame. He was a real eclipse fanatic, and he observed one from the London area, and his map comes pretty close, considering in the age way before computers and artificial calculators, that he came really close. So it's really cool to think that people who lived 300, 400 years ago even had this much knowledge without the benefit of what we have today. So how to help kids observe the eclipse. I've taught for a number of years, and I've had several eclipses occur during that time, and I've had all different age groups. I was director of my districts in Portchester, New York, the planetarium. So I was actually my responsibility to make sure everybody saw the eclipse safely. And I have to say, to my credit, our administration never gave us a problem with that. We always were allowed to take our students out, and we always had a really fun and safe time. For those who are worried about younger students, say pre-K, K to 2, maybe you're afraid of them not holding their glasses properly or anything. And we're going to get to these later on. There's plenty of ways for the younger, younger guys to watch an eclipse safely without even looking toward the sun. April 8th, we'll have some leafed out trees in a lot of the U.S., maybe not northern New England or even upstate New York, but certainly for those in the South and maybe even the Midwest, you'll have some leafed out trees. Gather the kids, take them outside, put them under a tree. This way they're sufficiently blocked from even looking at the sun, and they'll be mesmerized by all the crescents that'll be flooding on the ground. We've included some photos of this to show you later on in the presentation, and that's always fun. I mean, even as adults, we're just like, wow, this is so cool. You'll watch adults break out their phones and take pictures of the crescents on the ground. You could spread out a white sheet. You could have kids bend over and have the crescents on their back of their shirt and have someone take pictures of them. It's a really great souvenir. Also, colanders are great too because they're handy. Almost every kitchen has a colander. You could hold that over a white sheet on the ground. I've got pictures of this too coming up, and they make a really nice pattern of crescents on the ground as well. I like to have a pegboard that you can punch out, or your own board, punch out holes and make a message. You could say, the date, the school, maybe the kids' names, Eclipse, April 8th, 2024, and punch them out yourself. Don't make the holes too large or you're going to lose the sharpness of the image, but you could actually make your own messages. Pegboard is great too. Everybody's got something with little holes in it, so that's pretty easy. Pinhole viewer construction is also pretty simple, and that's a good engineering task for science and engineering principles with NGSS. There's plenty of ways. I use a FedEx triangular mailing tube, which works really well. And the larger, just remember, the larger the length, the longer the length, the larger the image the sun will be projected inside. Again, very safe way, because when you use it, you actually have your back to the sun's over your shoulder, and you're not necessarily looking in the direction of the sun. As Shawn and I were talking yesterday, we all had some people who say, do I look through the pinhole? And the answer is absolutely not. That defeats the entire purpose. So I wrote article for Dig Magazine, Cobblestone Media back in 2017. I'm going to give that to Denise and Shawn and have them post it too. It's got like 6 simple steps how to make a viewer. And then Eclipse glasses, obviously they come in all shapes and sizes. Shawn and I were talking that we like these for the younger kids because sometimes younger kids will have a hard time with the stems, putting the stems over their ears. I just happen to like these in general anyway. As an adult, it's just easy because you're not going to be staring for, straight minutes at the sun because there's nothing much to look at after a few seconds. So the ideal way is to just put them up every 5 minutes or so to see the progression of the eclipse. So I like these for younger kids and older kids, in fact. And they come in all different, you can have ones that have more of a protection, so you have more of a shade. And on my own website, scienceinsideout.com, I'm going to be putting up templates for designs kids can actually cut out with heavy cardstock or cardboard, and they're going to fit right over these glasses, so they'll actually protect them up to about here and around this way. So there's really no chance of them accidentally stealing a glance at the sun, and they can put their own souvenir markings on it, the date, and color with crayon. It's a lot of fun. I did that the last couple of eclipses, and it's a lot of fun. And the other thing I have a picture of also later on in the show is image projection. It's a great way for a whole class to watch the eclipse progress. Take someone who's got a telescope and knows how to use it properly. It's properly, used by an adult. Don't let any students near it. And you can project an image of the sun 10 or 12 feet away onto a white sheet or a whiteboard that you can bring outside. So there's plenty of safe ways to watch an eclipse, either directly or indirectly.
So this is just a demonstration of what the pinhole viewer can look like, especially if you use a box. And we just wanted to do this to emphasize you don't look through the hole, no matter what you do. And you don't have to use a box. You can use just a sheet of cardboard with a tiny hole in it and do it and project it on paper on the ground. There are any number of ways that you can use this approach to view the eclipse. And then if you want, this video from Ready, Jet, Go is available on PBS Learning Media. So your young ones can see exactly how this looks and how it works.
Hey, viewing eclipses safely, there's 2 ways to view an eclipse, directly and indirectly. Obviously, the safer way is indirectly, but I have never had an issue with either adults or students looking at an eclipse directly because we practice, safety first. And please know that no matter what anybody tells you, sunglasses, CDs, soda bottles, I've seen people attempt all kinds of crazy things to protect themselves while they watch an eclipse. None of those are safe. You really have to use the aluminized mylar that makes up the protective film in this. Back in the day, you could also use black and white, fully exposed film, 3 layers. I did that, but now they don't, who can get film anymore? And if you could, who can guarantee there's enough silver in it? So the only really safe way would be to get from an approved vendor, get either glass or mylar solar protection devices. And I love these because it makes the sun a pleasing orange color, and it's just cool looking at the sun directly. Again, if you have nervous administrators or nervous parents, you can always say, okay, we'll have the kids look indirectly, which is just the fact that they're outside is what really matters. You also have to have a 0 tolerance policy. Schools, as I'm a longtime teacher, we've had 0 tolerance policies for many things, and this should be one of them too. And we've actually had some teachers say, what do we do if the kid? What do you do? You take the kid and say you have to go inside. There's 0% tolerance for this. So you don't want to ruin it for the whole group, and you don't want to have kids never be able to go out again because a couple of kids maybe thought they didn't need to use the glasses. So you have to have your teacher's aides on hand. You have to have maybe have a group of teachers and you're all watching the students to make sure that they are using them safely and correctly. And again, this is why I always practice with my students. I take them outside for days in advance. We pick our spot. We make sure it's a clear sky. There's no building obstructions. No trees are going to be in the way. And we talk about the roles students have. We'll get to that later. But anyway, so yeah, just want to make sure it's that there's no fooling around. There's no 100% adherence to the safety measures. Never have the kids wear glasses walking around, because there's been incidents of kids who were told to wear the glasses while actually walking out of the building to the place to watch the eclipse. because of course, every eclipse has magical rays that bounce off things and go into your retina and blind you, according to some people I've heard, which is completely ridiculous. The sun is just as dangerous on any day as it is on an eclipse day. So I tell principals and superintendents, hey, you let your kids out in the playground on a regular day. How come you have no problem there, right? So never let the kids walk around with these fully on, because they're going to trip and slip, and then you're going to have to worry about other things like that. So make sure they don't put these eclipse glasses on until they're in place at the area where they should be. And they should be securely fitted. If they're using STEM glasses like this, make sure they're firmly around the ears. What I've done sometimes is take a rubber band and make a rubber band fixture, and it goes around the back of the head. But make sure, again, if the minute they move to go back inside, the glasses should come off, and they shouldn't be looking with these on the full time anyway. Next slide. These are some of the many, many, many students that I have either worked with outside my district or within my district. I've gone to a lot of NSTA conferences, and I've distributed lots of classes at the conferences. And what I like about these pictures is that when you have a hesitant administrator, and there are some, I learned a lot from 2017. That's why I created a program called No Child Left Inside, which is going to be part of my my website. I'm actually putting the last finishing touches on it. So I like to show these pictures, because when an administrator sees that these kids have actually seen the sun safely through these, it makes it think, okay, well, if a kid this young can do it, why can't a high school kid or a middle school kid, or even, kids their age do it? It's not that I want to shame any administrator, but I do want to make them think that, hey, why are you arbitrarily keeping kids inside, robbing them of one of the coolest things they'll ever see? And isn't the job of the school to be an education place and not a place to withhold education? And to me, it's actually criminal when somebody would keep kids inside and a teacher inside, denying them the chance to see even a partial eclipse. It's absolutely unethical to me. That's why I show a lot of pictures of kids using the glasses safely. Next. Do you want to take this one? Up to you. I could do it if you want.
Our picture is gone. You can take it.
Okay. Our picture is gone. Yeah, I don't know what happened to it. Yeah, youngest learners should be assisted by teachers, parents, and teachers' aides. And again, with rehearsal, you don't want to go out there on April 8th and say, oh, what do I do now? Or, gee, I didn't plan for that to happen. And you want to, go out and do a dry run, like what we do, like with a play, with a musical, with a concert. This is, or with a sporting, event. This is just as important and just as necessary to have rehearsal for that. Again, I talked about already about the solar viewers. I have both types on my site too, and other people like PBS have glasses, and so it depends. I would say K2, definitely go with the rectangular ones like this, and grade 3 and up, you could probably go either one. But again, these are really cool, but the other ones have their place too, because they're actually kind of neat. They're a little more fashionable, and kids get a kick out of wearing them. So I would say 3 and up, you have your choice, and K2, the rectangular ones. And again, I'm going to have a template to make it even a larger shield to put over them. So this way, it should reduce every principal, superintendent, parent's fear that kids will not accidentally, be looking at the sun. And again, we're out in the sun all the time. The sun shines indirectly on us. We don't stare at it, but we do catch sunlight, and we're perfect. We're fine, right? So this is what you have to say, that this is going to be. You have to convince your administrators that this is going to be a perfectly safe activity. If you need to get the activities to show that it's going to be STEM, that's great too. And there's plenty. Everybody's got plenty of PBSs. The Learning Center, it's a wonderful site for all kinds of different activities. You can find those anywhere on the web, but PBS has some really, really good. I'm a big PBS fan for years, so I'm kind of biased in that. I use PBS all the time. Again, we talked about pinhole, under a tree, group projection. Next slide. And this is kind of cool. This is a new one that I did in 2017. This is a sun funnel, and you take mylar or other kind of lightweight material, and you actually make a funnel, and it slips over the telescope eyepiece projection. And again, this is for people who really know how to use a telescope. You don't want to pick up a telescope the day before and say, okay, I can do this. No, you want to be a seasoned telescope user, or find somebody who is. Find a science person in school, or find a planetarium director, or find a science outreach person, a retired, a retired teacher. People are more than happy to donate their time, as I've done. I've donated, and all of us have many hours of volunteer time to this. So that's kind of fun. Kids, and so a group of kids can look at it at the same time. Again, there's the Eclipse classes on the left. Next slide. Eclipse crescents. Now, this is interesting because the photo on the left, the image on the left, that was taken at a prison that I did outreach at in last September in the Houston, Sugar Land, Texas area. And I got permission, secured permission for the inmates to actually go out on October 14th and take measurements and do some STEM activities, including making a punch-out card, which they did perfectly. And it was the coolest thing in the world to be back in New York and to see the inmates through the principal having written me with their pictures, and they were so proud of themselves for having done the experiments properly, and it just warmed my heart. I kind of have a special affinity now for alternative education places like that, and I plan on actually going to more prisons this month and doing outreach with them. And of course, there's a colander on the right hand side. You could see the thick crescents of the sun shining through the pinholes in the colander. Next. Here's some eclipse crescents flooding a side of a house, flooding a walkway. And this, I said, I mean, this is a great way for kids to see it. It's very overwhelming, actually. Visually, it's really cool. And I don't know any adult who hasn't thought this was very cool either. So this is just a really lovely, wonderful way to show an eclipse safely without, having to worry about looking up and everything because the trees block the sun, naturally. And every opening between the leaves produces a pinhole image, the way you would do your own pinhole viewer. So it's kind of a natural pinhole camera, but thousands of them. It's a very, very cool sight to see the eclipse progress on the ground. And this is from Life magazine, 1963. The kids made their own eclipse viewers. And again, things got a little trendier and hipper over the years. So there's plenty of ways you could do art teachers. Again, my No Child Left Inside, I have projects for every teacher in every school practically, and art teachers love getting involved with this too. They can help the kids using a template, or they can design their own and make their own souvenir shield with the date on it and the name of the school, and the kids can sign their names, how old they were. It's a really good souvenir. It's fun. You want to do this one, Shawn? I've been talking a lot.
Okay. These are just some ideas for some related activities. There are lots of different types of observations you can make during this. And it's a good idea, no matter how young the kids are, to have them record their observations, not just what they're seeing, but also the sounds and how it's changing and how they feel about it. They can even seal their observations in an envelope to save, to show their kids, and open it up in 2045, the next big eclipse that's going across the country. While you're outside, you can pause and do some modeling to scale of the Earth, Sun, Moon system. If you're on a bus to totality, you can prepare a little trivia time and have contests left to right. And you can make a real time capsule. I think Charles has some pictures of it, including the pictures of eclipse, class photos, things from school that can be dug up at the next eclipse. Just make sure that you leave lots of good records as to where it is and
yes,
find it.
There's cases of time capsules being unfortunately lost for posterity because they didn't leave good records. This is a picture of actually kids and with the guidance this is kind of a very, very cool one. They're actually taking bricks apart, but you don't have to do that. You can just kind of take a hefty bag and line a little ditch that you've dug up and put it in there just to kind of water seal it and stuff. And then, just put the soil over it. Just make sure your container obviously is not biodegradable, preferably glass, or they actually sell time capsules now online. I'm a big fan of doing it myself and not getting some cheap plastic thing. I'd rather use my own glass container. This way, kids can decorate it themselves, and they could each put their own artifacts in there in one large one, or they could have little time capsules for themselves. and you can do leave photos. You can leave clippings from newspapers, things like that. So there's anything you want, you can put in there. It's really cool. It's a fun thing for that next generation to dig up.
Okay, so a couple other activities and ways to prep for especially the younger kids. When the early elementary students should be thinking about like patterns of the motion of the sun and moon in the sky. So before the eclipse, you can take them out, get a routine set and start making observations of the moon when it's out during the day a couple times to try and predict the path, and the same with the sun. So you've got this routine going. So by the time it's the big day, then there's just like the one change that they have to make. And they already have kind of a routine going as far as making observations. This here is a simulation. We can play it, and it goes through a full lunar cycle. You can see that sometimes the moon and sun travel together. Sometimes they don't. They can make predictions about when in the cycle might be the best time for the moon to cover the sun. And think about what's similar and different about the moon's and sun's path. Next slide, please. And so likewise for late elementary, they're figuring out why the moon and sun like rise in the east and set in the west. And this is a simulation that they can use that helps them connect the Earth and space perspectives and to figure that out. And again, you could go out and should go out and take some real measurements to complement or real observations to complement the simulation, and that would get your kids in the routine of making sky observations before you go out to observe the eclipse. Next slide, please.
Data collection's one of the coolest things, and it's also one of, to me, it's a necessary thing because now in the age of STEM and GSS, it's really good to have activities centered around the eclipse. And it's good because you could actually lead up to the eclipse with practice exercises, investigations, inquiries, things like that. Again, PBS, NASA, my site, plenty of other sites, Dan, eclipse2024.org, Dan's site, greatamericaneclipse.com. There's plenty of sites that have good things for you to do for the kids. Some of my favorite things are doing a line graph temperature change over the course of the eclipse, beginning with first contact, which is when the moon's disk is tangent to the sun's disk, and then over the next 3+ hours, noting the change in ambient temperature. Usually it will dip down and decrease, and it'll be a nice kind of dip, and then it'll come back up again as the eclipse progresses and the moon moves off the sun. Ambient lighting change is great. You can also take a photo meter like the kind of professional photographers use, and you can because don't forget, guys, our eyes are very adaptable to lighting changes. So our eyes are not a good indicator of actually how dark it's getting and how dim it's getting. If it is, it's better to have a light meter that you set on manual, and you could just check the readings every 10 minutes or so, and do steady intervals. Do 5-10 minutes. 10 minutes is usually a good interval to get a little bit of change at least. I love animal behavior. As I said, I'm fascinated by watching birds get confused and go back thinking it's roosting time. You could have somebody who's like a very good, natural, as Howard Gardner would say, a naturalistic intelligence. You could have them note any changes in animal behavior. I also note change in human behavior, especially as the last 30 seconds before totality. People are pretty calm during a partial eclipse, but when that last half minute before totality comes, it's like everything just goes crazy, and I get chills just thinking about it. And already 7 years later, I'm still feeling it when I think about that. And that's when I take time to look around and I notice who's screaming, who's shouting, who's swearing, who's crying, who's doing nothing, who's awestruck. You get the whole range of emotions, and of course, you don't have to quantify that in the STEM project, but it's just kind of fun to note how human behavior works too. Notice the clouds in the sky. If they're cumulus clouds, as long as you don't have a heavy front, like an overcast kind of front weather, which I hope you don't, cumulus clouds will tend to dissipate, which happened to me in 1999 to me and my family in Austria. It was raining actually about an hour before totality, and as the weather cooled because of the advancing moon over the sun, the clouds dissipated. We saw totality perfectly, And wouldn't you know, 20 minutes later, it was raining again. So don't fear if you have cumulus clouds, sometimes stratus clouds, they may go away. Again, and I'm not a big photographer of eclipses. I tried and failed miserably my first couple ones. And I said, what am I doing? There's going to be a lot of professional photographers taking really good pictures. Just sit back, relax, work with your kids, enjoy it, and don't forget to look up and take it in, because totality is such an otherworldly experience. Your brain simply doesn't know what to do with it. And I struggle to remember like what it was like. I have a vague, image, but to remember exactly what those prominences look like, the color of the chromosphere, the diamond rings, the corona. It's so overwhelming because it is truly an otherworldly experience. You're standing in the shadow of an object 250,000 miles away, pretty much, and you could feel the onrush of the shadow. You don't feel it, but you feel it in your body. It's an otherworldly experience. And if anybody goes to their grave without seeing a total solar eclipse, I really feel you haven't lived the fullest life you could have, and I truly mean that. This will be my sixth one, and I can't get enough of them. Still, I travel the world to see them. I've been to 4 continents, all because of things like this. So to have kids do these lessons and make it memorable for them, and they'll have souvenirs, and they'll have their line graph even as a souvenir. I have things from the 1900s, 1990s still, the kids did. It's wonderful. And then there's collaborative projects like Mega Movie, which I'll put on my page as well. There's lots of interactive things you could do with kids across the country, especially at the high school age. Anyway, there's a lot to do, so you can feel free to check out our links and everything. This is me in Naperville North High School outside of Chicago, where my sister and her family live, just doing a little outreach with them. Next. And this is the aforementioned prisoners in Sugar Land, Texas at Jester 3, a unit that's a medium security unit. My first time ever in a prison like that. And I was intimidated for about maybe, I don't know, 5 minutes. And then they were great and we had a great time. And I spent a full day with them. And they just did a wonderful, wonderful job. And it really makes me want to teach in an alternative environment after being with them. And I'm looking forward to my next prison visits coming up in March. Preparing. Want to take that, Shawn?
Yeah, go ahead.
Okay, you can take the next one then. Okay. Yeah, very important. Make sure there's no scratches or pinholes in your Mylar glasses. And one way to do that is to go outside, look away from the sun, hold it up to the sky. If you see any pinholes at all or any kind of scratches, ditch it. Okay, these are cheap. They're not worth your vision. Okay. Also, if you look at it, say a halogen light or an old-fashioned incandescent light, a mercury vapor light, you should see the filament, but that's all you should see. You should not see any glare. So that's another way to test. And then again, just make sure to reassure your principal, your superintendent, your parents that you have inspected the glasses. It's not enough to buy them. You have to actually inspect them yourself or with somebody you trust, like maybe a science. If you're not a science teacher, grab your science chair and have him or her take a look at that as well. Anyway, if you see anything that's raises concern, throw the glasses away. Don't anybody touch them. And also, again, the pinhole viewer is safe. I have instructions for just about everything PBS does, AAS does, NASA does. So there's no shortage of instructions on how to use things and what to do with them. You can look for a museum that's hosting viewing party. Rochester, New York, where I'm going to be, has lots and lots of things going on too. And please, if you're close to totality, please drive there, get the bus tomorrow, reserve it. Have a fundraiser, sell Eclipse glasses. You'll make a good profit on those. And Eclipse glasses are a wonderful fundraiser. I've done them for years that way. And the PTO makes some good money, and our astronomy club makes some good money. And it's a very simple way to make money. And I tell schools, you would have no problem driving 100 miles for a football conference championship. Well, this is even better than that. So there's no excuse if you live within 100 miles or say 50 miles if it's less convenient to go to totality. It's totally worth it, even for a day trip. On this one, Shawn? Okay. Lots of reliable websites for information and resources. Again, try to avoid .coms unless they're a reputable .com like Great American Eclipse, things like that. Eclipseophile is a good one. Jay Anderson in Canada, very, very excellent meteorologist. He's got weather prospects on eclipseophile.com. Again, generate community awareness, put up posters. Tyler Norgren, a friend of mine, does wonderful posters. If you look up Tyler Norgren, he's got some retro looking, like Art Deco looking posters, very, very cool. And everybody will receive a follow-up email with all these things we're talking about. So if you feel like you missed it tonight, don't worry about it. And this will be archived. So if you missed anything, just feel free to review this again. Make sure you go over your agenda with your administrators for approval, parents' permission. Again, some parents can be very nervous about this, and some administrators can be very nervous about this because they have been. I've had to talk to administrators on behalf of teachers, and I have printed out a form letter. That's a very kind yet firm form letter, very professionally written, but firm. And it says how, number one, you can't deny students this opportunity, whether it's partial or especially if it's total. If you have the fortuitousness of having totality come to your doorstep at your school, and you keep your kids inside a classroom, you should not be an administrator anymore because you failed your students. And I truly believe that. And this happened in 2017. So I do have form letters if teachers, I'll be happy to talk to administrators too. I won't mention any names. I've done that before, and it did work actually. Go outside, do a little reconnoitering, make sure that your area is free of obstructions, whether it's buildings, trees, anything that could get in the way, telephone poles, power lines. Make sure you go out a week before at the time of the eclipse and make sure the sun is in an unobstructed portion of the sky, and get those buses reserved for the path of totality now, or you're going to be shut out, unfortunately. Okay. Again, yeah, I have teachers, we like to take things and share things, and I've both taken and shared, and I have really good Eclipse integrated lessons. PBS obviously has a ton of them. Other teachers do too. And again, my website is, when it's done, it's going to be a clearinghouse for all different things for teachers to do. So there's plenty of variety for special needs kids, for LD, ED, English language learners, or when they say English as a new language now, again, incarcerated students, even blind students, hard of hearing students. I'm working with them all. So I don't care what type of student you have, that kid should definitely see the eclipse. And if bar nothing, it's that memorable of an experience. Talk to a local amateur astronomer. I was a planetarium director for years. People came to me all the time. They still, look at PBS's resources. They're wonderful. Schedule a trip to your local planetarium and practice beforehand. And plan B, you always have to have a plan B, right? If it's cloudy, you might still see a change in light, especially if you're close to, about 80% of coverage, you will definitely see some ambient lighting changes. So still go outside. You might have a crack in the clouds. Don't just stay inside because it looks cloudy. You may get lucky. You never know. And we talked about, Shawn showed you before, how a 99% sounds really good on a chemistry test, but it's a lousy eclipse score. And I always tell people that. To me, it's totality. Of course, obviously some people can't do it, but to me, it's, totality or nothing if you're within shot of it. If you're in the same state, if you're in, within a couple hundred miles yourself, or maybe 50 miles with students, you got to get to totality. I've traveled to Shanghai, to Patagonia, to Salzburg, to a few other places. And I tell people, why would I spend all that money and time to travel the world if it weren't the most incredible thing you'll ever see in your life? And people don't miss what they don't know. And totality is a perfect example of that. If you've never seen totality, I feel sad for you, because if you're going to not see it this time, but there's always going to be others ones. There's going to be ones in Spain in a couple of years. There's going to be ones in the Middle East. There's going to be ones back in the US again. So if you miss this one, you can always wait till you retire and see it then. But please try to get to it if at all possible. And we could show a couple quick seconds of this. This is a bird's eye view by Michael Zeiler, creator of GreatAmericanEclipse.com. And this shows a bird's eye view of what the shadow will look like, greatly speeded up, of course. And it's got all the situational things on the left-hand side, the duration of totality. You can see the time of day, the speed of the umbra. The umbra is traveling at a raw speed of about 2,000 miles an hour. But when you add in the Earth's rotation in the same direction, it brings it down to about, less than 2,000. In fact, as slow as 1,000 miles an hour in some cases if you're close to the equator. So there's a lot of geometry, a lot of mathematics with eclipses too. And I always tell teachers, no matter what you teach, I have a lesson for you, and so does PBS, and so do other people. Doesn't matter what content you teach, spread the content around, share the content, do cross-cutting concepts, science and engineering practices, disciplinary core ideas. You know the works with NGSS. And if you're an elementary teacher, I feel for you because science takes a second hand a lot of times to ELA and math. I feel for you. I will help.
Okay, so
Was I muted all that time?
now for a second.
Oh, okay.
Just for
Sorry.
a second, we need to move on to our
Okay.
colleagues at Nova.
Okay. Thank you very much for having me tonight. Really appreciate it.
Okay, turning
And
to Nova, and she's gonna tell you all about a couple events that they're hosting.
Awesome. Thank you guys so much. We at Nova are also super excited about this eclipse. It's a great opportunity for STEM education, and we've got some really great programming coming up. So first and foremost, we will be premiering Nova on the Great American Eclipse. That is the title. It's premiering on April 3rd, which is the Wednesday before the April 8th eclipse, and that will be premiering at 9:00 p.m. Eastern on your PBS station, or you can also find it at the Nova website or our YouTube page. So a great way to get excited. Additionally, it is, awesome. It is also Nova's 50th anniversary this year. So we're really excited that this anniversary is coinciding with this awesome celestial event. And we are producing a ton of Nova 50th anniversary solar eclipse glasses, which you can register to. We'll send them to your address. So register for those free glasses. They're high quality, great glasses, limit 100 pairs per request. And we'll give you guys a link to sign up for those. But yeah, great to order for your classroom. And yeah, very excited about that. And last but not least, we will be doing a virtual field trip from the little town of Kerrville, Texas. It's in the path of totality. They're hosting a pretty big festival there. NASA will be there. So we will be broadcasting that. It's actually going to be at 12 p.m. Eastern. So just a little correction from that slide. But yeah, we're really excited to talk to some NASA scientists. This will be a great opportunity for, kids, and as well as just anyone who happens to be watching the live stream to ask questions of NASA scientists and just kind of share in the excitement of the moment. It will be prior to the eclipse, so we will not be live streaming the totality itself. We're just going to be asking questions of scientists and just getting excited about the science, and then, encouraging people to go outside. No kid left inside. I love it. So that's kind of what we have going on at Nova. I'll drop those links into the chat so you guys can register for Eclipse classes and also register for the virtual field trip on April 8th.
Thank you, Tara. That sounds really fun. Little Eclipse Festival. So I hope you all have a chance to sign up for that live stream and get your glasses. So I'm going to move pretty quickly here so that we have time for questions. Before I do that, I want to really thank Charles for joining us tonight and providing all of that great information and your enthusiasm and passion for viewing the eclipse. And also thank you, Shawn, our director of STEM here at GBH, for bringing all of those great resources. And just a reminder for folks to check out pbslearningmedia.org. Next slide. Nikki, if you want to just sort of page through these slides just to show folks what some of these resource collections are like, and please visit our YouTube channel. We have lots of other recordings of great STEM webinars for you and help us do better. We want to hear what you thought about tonight's program. So here's a link you can go to, and once you complete the survey, you'll be able to download your certificate of attendance, and all of the links, again, will be in the resource document. So I'm going to leave the chat open if people want to hang out. And I pulled a couple of questions as they came up. Oh, geez, if I can find them.
Some questions that I noticed were people were asking, well, what if it's a certain amount of percent? Like, what's it going to be like? You know, I think anything over about 70% is noticeable. And like the last one, I was about 75%, and it still gave a different kind of feel. And you know, kind of like that weird feel before a storm when you're thinking there might be a tornado, even though it was not a cloud in the sky, you know, I mean, so it's like a weird feeling. And then another time when I went to an annular eclipse, it was like 93%, you know, it gets dark, twilight, animals are quiet, you know, I mean, so a lot of the things change. It just didn't get all the way to darkness. And, you know, we could never look at the sun without the viewers. So it's a really cool experience, even if it isn't totality. But if you're close, just go for it if you can.
One question that we got earlier in the program that was pretty specific. I like it. Why are there two parts to the shadow? What causes the outer, lighter, hazy shadow? It's kind of hard now because we're out of context of where we were. But we'll think about that and see if we can pop something in the resource document for you. Here's another one that might stump us. How long until the moon moves further away enough to never appear big enough to have a total eclipse?
Well, that's going to be millions and millions of years away. In fact, I was
Okay.
thinking of writing, oops, hold on. I was thinking of writing a short story about that, actually, called The Last Totality. And I don't think humans will be around for this, unfortunately, but it's going to be very interesting because there's going to be that one last totality, which will last maybe a fraction of a second. And then after that, it's only going to be annular eclipses instead of totalities. And that's not anywhere in anybody's radar right now. It's millions and millions of years down the road. Because the moon's moving away from the Earth at about 2 to 3 inches a year, a few centimeters a year, and at that rate, because of tidal locking and everything, and the closed system between the Earth and the Moon, as the Moon will actually gain distance away from the Earth, there will be a time way down the road when you only have annular eclipses instead of totalities. But we don't have to worry about that now, thankfully.
We have a couple comments in the chat. Charles, I think this is one for you about having some sort of letter of,
Oh yeah,
support letter for the glasses to show that they're authentic and safe. And
yeah. In fact, every time you order glasses, they should come with an authenticity certificate, which is what mine do. You want to look for the CE. It's called CEIS certificate. And that means that it's been examined, not only manufactured under precise circumstances, but it's also been inspected too. So you want that CEISO certification stamped onto the glasses. And they are also, 2017, we had that problem with a lot of what they called, fake phony glasses being sold on that A word website, which shall remain nameless. But that's already a problem again. They're already flooding the market again because people did buy them, and people were not allowed to outside once they found out they had the pseudo glasses, the not verified glasses. So it's really important to go through accredited vendors. The AAS has accredited vendors also. I'm one of them. You guys obviously have them. There's a bunch of people that are accredited vendors, and those are the ones that you should go through, not just go randomly onto Amazon or something.
So, and also that, like Charles said, that there is a list if you can't get the free ones from NOAA. But it's in the list. It's in our document, and it's what the American Astronomical
Society. Yep.
They have a list of reputable, as far as they know, reputable distributors. So go and order from there to feel more confident. As far as the umbra penumbra, so so it's because like when all the light isn't blocked from the light source, then some of it is going to travel around and so that, I mean, that's the reason why. So
Yeah, anytime you have a disk of light, you're going to get a penumbra. A point of light like a star won't produce that, but a disk will, like the sun.
Hmm.
For what Sean just said, it's got an area. It's got area to it.
right, it's because the light source is bigger than the
Right.
sun. So like a faraway star is like a point source, but the sun is much bigger than.
If anybody has any specific questions like that, you can always email me at totality2024@gmail.com. I try to answer all the questions as soon as they come in. Sometimes my days are crazier than others, but if you want to email me, I put it in the chat, totality2024@gmail.com. Ask me anything and I'll try to get back to you ASAP.
It's like an Eclipse hotline.
Yeah.
All right,
Yes.
well,
I will help out as well. So,
Right.
we
Yeah,
should
sure.
wrap up. Charles or Shawn, were there any other questions that popped for you in the chat that you wanted to address?
Oh yeah, just a couple people were talking about like helping them out with getting approval and stuff. I will certainly work with any teacher. I won't even mention the name. I'll be happy to be the proxy for this and try to, I have ways of doing this, and they worked in 2017, and a few have worked already. So just let me know if you have a problem with your administration, and we'll talk about it and we'll figure something out. So you can get back to me by email there too, the same email I gave. And you could also reach me at scienceinsideout.com also. So 2 ways to reach me.
Great. And we'll have all of that in the resource doc. So
Great.
Again, I want to thank everyone. Thank you to all our participants and thank you to our panel. Tara from Nova, thank you. And we'll look forward to the live stream. And Charles, again, thank you very much.
My pleasure. Thanks to
Um,
everybody who tuned in tonight too.
my colleagues, Shawn and Nikki, yeah, we had a great turnout. So that's wonderful. So good night, everyone. Thank you.
And thank you, Shawn.
Good night. Thanks for coming.
Thanks,
Yeah.
everybody.
Thank you guys so much.
Clear skies.